Data warehouse is a subject-oriented system. Subject-oriented in the sense, this groceries belongs to one subject. This petrol belongs to one subject. So it is segregated as subject level. Right? Because this system, we call it as a subject-oriented system. And non-volatile. Non-volatile means whatever the data exists under the data warehouse, that data will not be deleted. The data will be saved under the data warehouse. The data will not be deleted and changed. This we call it as a non-volatile. And time variant system. Time variant means whatever the insertions, updations need to perform in a data warehouse, those insertion updations only on a timely basis only performed on a data warehouse. Timely basis in the sense, see, to move any data into a data warehouse, we have a certain time periods. One day data, end of the business day, like COP, closing of a business. After that, we will load the today's complete data into a data warehouse, or else 1 week data, or else 1 month data, quarterly data, half year data, and 1 year data. This way, we'll move the data into a data warehouse. Any insertions, updations will be performed on a timely basis. On a particular time only, that insertions, updations will be carried out. That is about a time variant. And integrated system. We have seen previously we are integrating different source systems. Oracle system, DB2 system, file systems, SAP HANA sources, and cloud computing, any kind of sources. We can merge everything and we can load into a data warehouse. We are integrating. Integrated data will be maintained under a data warehouse. For that reason, we call our data warehouse as a subject-oriented, non-volatile, time-variant, and integrated system. What is fact table and what is dimension table under the data? We have two types of tables under the data warehouse. Those two types of tables are fact table and dimension table. Fact table contains numeric data, which are measures, and a dimension table contains descriptive data. Fact table, two types of tables we have under the data warehouse. One is a fact table and one is a dimension table. Fact table contains a numeric data and dimension table contains a true data. Thus, I'll give you one example. Employee number, employee name, and salary. I have employee number is 191, employee name is Shailaja, and salary is 10,000. So here, what is the measure and what is the descriptive data? Here measure, by seeing what, everyone will measure me by seeing my salary, right? By seeing my salary only everyone will measure me. By seeing my employee number they will measure? No. By seeing the salary only they will measure me. So for that reason, so here the measure is a 10,000. Even though employee number is a numeric data, it is not a measure. It's just a number to identify me. It's just identification. But salary is a measurable thing. So here under the fact table, salary will be moved. Under the dimension table, employee number and employee name will be moved. So this is the way we have to move the data. This is a fact table and dimension table, and we have a few more concepts on data warehouse. Those are how the data is organizing under the data warehouse. But in case of normal forms means what? One bigger table will be split into a smaller table. Following the, we have a different normal forms like first normal form, second normal, third normal form, binormal form. So like that we have a normal forms. So the first normal form will say the table should be with the primary key and unique index, and different kinds of the second normal form also have a foreign key, and to give the parent and child relationship differential integrity we need to maintain. So like that, it follows the normal forms. The structure will be something like this. It's a parent level table. This is a level 1 and this is a level 2 child. Level 1 child and level 2 child. So this is the way data will be organized under a Oracle database. But in case of data warehouse, how the data is going to organize? We have two schemas. The schemas are star schema and snowflake schema. So we have two schemas, star schema, and the star schema is a fact table surrounded by the dimension tables like star. A look and feel also like a star. In middle we have a fact table surrounded by all the dimensions. This is my schema, the fact table, and these are the dimension tables. These are all the dimension tables. So this is the way data is going to organize under data warehouse on schemas only. If fact table contains what? Only a measures. In case of dimensions, dimensions contains a fact table contains a measures and dimension table contains a descriptive data. My fact table contains, apart from measures, it contains a keys of the dimension tables to refer a dimension. Keys of the dimension tables to refer dimensions. I'll take some sample data and I have some customer details, customer number, customer name and customer address I have, and product details, product number and product name and amount, how much cost of the product and number of items purchased, number of, and store details, store number, store name, store address and date, time. So this is my sample data. Customer number is 101, customer name is Shailaja and customer address Bangalore and product number is 098, product name is Samsung S4. Anything. My product is Samsung S and cost 45,000. Number of items purchased, one Samsung S4 mobile I bought and store number is A001. Store name is Big C and store address is date as 12/10/2014 I purchased. The time I purchased at 3:30 p.m. I purchased. This data, this is my source. This data, how they will organize. This is not our work actually, how the data is organizing, how the table structures are, and we just have to let us know, because as a developer we go, as an Informatica developer means we don't need how to create this fact table, how to create this dimension table, we don't need all those. These are the only the work of DBAs, database admins people will be there. This DBAs will create all the structures and all. We just have to get a knowledge on these fact table and dimensions tables, what are all the columns exist in the fact table, dimension tables, then only we can easily move the data. See, this is my source. I don't know what is fact table and what is dimension table and what are all the columns exist under those tables. How can I move this data into a particular table? It's not possible, right? It is a bit difficult process. Because of that, we have to get an idea on a schema as well as how the columns are and all. So under my fact table, they will develop like this. Under my fact table, only measures will be there. On my data, this is my sample data. On my sample data, what are all the measurable things you find? So these two are the measures. This dimension, this is the customer dimension. Under customer dimension, I need a key, primary key. Customer number is a primary key and customer name and customer address. These three columns will come under a customer dimension. This is a product dimension. Under the product dimension, product number is a key, product name. These two only will get, because there are no other columns belongs to the product. This is a store dimension. Under store dimension, store number is a key, store name, store address. These three will get under store dimension. This is the date dimension. This is a time dimension. Always we have the conformed dimensions, two dimensions are there. These are the date dimension and time dimension, which will not be changed. Time is 24 hours and date, in case of date, year data. The data won't be changed. 1 year data, the month, what are the Sunday, Saturday and week data, and everything will be same, right? So date will change and time also 24 hours. It will run every time. That's all. Time dimension, the time key we have and time value, actual value of the time. And in case of date dimension, date key we have and date. This is my fact table and these are the dimensions I have. Under my fact table, apart from measures, what I contain keys of the dimension tables to refer. Here I'll write under the fact table what contains cost and number of items and keys of the dimensions, store number, product number and customer number. These are the keys of the tables. And date key, my fact table contains a measurable things as well as a keys of our dimension tables to refer the dimensions. Referential integrity will maintain, foreign key. So this schema is, star schema is a very simple schema, a fact table surrounded by the dimension table. In case of Snowflake schema, a dimension, then we call this schema as a Snowflake schema. Here, when they will make it as a Snowflake schema means whenever they feel like this dimension is very big, this dimension table is very big, on that case, they will split this table as two tables, two dimension tables, and they will maintain a referential integrity between these two tables, means parent and child relationship. So for example, this store address, with this store address, this store dimension is becoming a very big dimension. So for that reason, what they have done means store address they will maintain under a one more dimension, which is a store address dimension, whatever the address values and all, address column names and all will comes under a store address. Address means not only one column, right? Address means pin code we need, and also house number and how, which street and which state and which district. So many things will come, right? So those will, everything will be moved under another dimension, which is a store address dimension. They will maintain a referential integrity between these two dimensions. Whenever my dimensions have a child dimensions, in that case we call our schema as a snowflake schema. From different sources to data warehouse, in between Informatica came into the picture. Actually OLTP system means online transaction processing system will maintain a full data. But in case of data warehouse, under a data warehouse only summarized data will be maintained. Only for whatever the data necessary for analysis purpose, that data will be maintained. For that necessity means we have to implement business rules to get a required data. That business rules and all will be given by a client to us. So under the Informatica, what we are doing means we'll import different sources from the source systems and we'll merge everything. We'll implement some business logic on that, any aggregate functions. To summarize the data, we'll implement some aggregate functions and we'll move that data into a database.